Okay, this is a quick demo video. I went through the entire series, basically blocking out how we would take the basic set of requirements for building a small mini cloud platform. Went through some domain modeling, a little bit of physical deployment models. We did some text selections, implementation, orchestration, and integration. And now I just wanted to share a little bit about what I've been building and give a quick demo of what I have so far. Things are progressing nicely. The tool selections and the overall strategy is working pretty well, so let's jump right into it. Okay, what we have here is Netbox. If you remember, that was our inventory tool selection, and it just has some basic bare metal servers, inventory switches, things like that, and it has all the different features and characteristics of them. We have a set of buttons that I added in, so these did not come standard. These are custom buttons that I created for different controls, as you can see, for the actions you can take on a bare metal server. Additionally, some custom fields. You can see one of them importantly is the VXLAN for the EVPN solution. That also got added in as custom. Switching over to the interfaces, we have a couple different interfaces built out for this. I've also created another custom field for this, which was the purpose for it, so I can detect what the intent is for my interface. This is a data interface. Obviously, then we have a couple other different types. Another important one to take into account is the provisioning. So I have an interface that is set up to connect to the provisioning network, which we'll actually be showing here in just a second. Obviously, the whole thing is deployed on Rancher, Kubernetes. So, there's nothing but a bunch of just little applications and microservices. For instance, the IPMI that I use and that infra controller to intercept all of those custom links. Got some network workers to pull that network information. You can also see I've got some switch information getting pulled in the bare metal as well. So I can dig in there and find out which switch is connected to which interface. And everything, of course, works on messages. So they all publish messages. I've got Kafka in place, as well as we talked a lot about Vault. So all of my credentials are installed, stored in Vault. Got my IPMI credentials that I'll be using with that IPMI microservice. It reaches across, so there's no compromising of sensitive information or anything like that. We just have everything stored inside a Vault, and the application reaches across to Vault. So here I've got a nice little ASRock server. It's just a little mini machine that I use a lot of times to do bare metal, mainly because they come with an IPMI interface, and I can very easily set it up to be able to take the actions on it. They're nice, cheap little boxes. Really useful. So let's zoom out here a little bit so we can take a look and see what's going on, and watch the server at the same time that we watch the process model. I've built out a pretty basic process model that we'll go over here in a second. It's going to walk this server through all of its paces and get it ready to provision. We use that provision button there to kick off the process itself. You can see there's a bunch of different tasks in here. It's mostly about gathering information about the server itself, switching its network, getting it onto that provisioning network, so turning that network interface on, getting it switched over there, creating all the VXLAN information and configuration, burning the image. Again, I use Clonezilla for that, and then, of course, switching it back over to from the provisioning network over to the data network. Kind of do a final reboot. And since I'm up and running with a new switch port and using that data port, then and not using the provisioning network anymore, then I'll boot onto the 10.0.2 EVPN network that I have created. So at that point, we should have connectivity. So we've kicked it off. It's already started here, so it's grabbing up a bunch of Netbox data. It's already jumped through. Yep, there it is. It's already rebooting at IPMI reboot, so it moves very quickly. It just pulled all the data it needed from Netbox and went ahead and kicked the server over. We've already swapped our server ports, so it went and found all that information in NetBox to figure out, where all of the connections were, and then talked to the switch, and turned off the ports that we didn't need, turned on the ports that we needed. So right now we're just doing an IPMI boot. It should boot into my agent. Once it does that, then it will run some scripts with OCSSR, which is the binary primarily sitting behind Clonezilla. Here are all those variables I was talking about. So it pulled all those from the NetBox information and put them on the process. Obviously, MAC addresses, IPAs of the switches, different ports that I want to turn off and on. Most importantly, obviously, the VXLAN, so the VNI. So there we go. I'm going to go ahead and skip a little bit here, but that is the agent running right now. It's a bit bloated. I need to carve it down a little bit. So, it doesn't take quite so long, but we went ahead and used all those credentials. I also have credentials for the SSH FS mount, which is where the image is going to come from. So I've skipped ahead a little here, so you didn't have to sit and watch that agent load. I desperately need to pull some things off that agent right now. It's heavily debug, but I will strip it before I use it on a regular basis. So we're booting into the agent, and there will be a first boot script that will then run, do the SSH FS mount, pull the image across that we designated. That was a custom field designated on the NetBox. I can also capture those images from the same sort of process. So I have a different process model that I use to reboot the server. Does the same thing, puts it on a provisioning network, and then, captures the image rather than burns it down. And then you can just basically capture images and reblow them back on, do, BIOS configurations, things like that. So our images have been laid down. We are rebooting, so you can see we've progressed on the process there. It's been a little while. I skipped ahead so we didn't have a 30-minute video going here. But, okay, so we should see, there we go. It's going to try and Pixie boot again. Obviously, we've flipped our switch ports again, so it should not DHCP and Pixie boot. So we should just let it spiral here for a second, and it'll realize that it's not going to be able to make a connection there, and kick itself back over to do a disk boot. So we've set the boot menu on the priority on the machine to first try and Pixie boot if it can, and then if it can't, boot from disk, which should be the OS image that we laid down, which was a Ubuntu 20.04 server edition. So that should come up here in a second. Give it a minute to kick over. There it goes. It's coming back up. So again, this was just very simply, boot into RAM, lay down the image, go ahead and let the image boot back up again. There we go. It's booting into 2004. And again, I can capture these as well, so it's not just, kind of a one-way street. I can set up a new server in my lab however I like, and I have one of these processes that you see here on the left for the provision. I've built one out for capture as well. Very nice because each task has a Kafka message. So we'll get into that a little bit later, but the messages themselves, if something goes wrong, I can jump in and take a look at any one of these tasks and then decide if I want to go ahead and copy and inject synthetic information into a message, and then it just sort of kicks the process back in if something goes wrong, reset things, and there we are. So we've booted in. Looks like we need a refresh. Yep, there we go. Process. This is ZB. Kamoon does operate. That's a pay for, I believe, but for dev purposes and things like that, you can absolutely use it. So Cloud Init has run, so we have leveraged Cloud Init to assign our IP address information and everything like that. So we should have a functioning server at this point that is no longer on my underlay network of 192, blah, blah, blah. I've now established an overlay network I've created a couple little fake smart NICs with some little NanoPi boxes and basically made them little EVPN devices. I can plug in the interfaces from my bare metal servers to those, and then obviously for my virtualization, I can just use OVS or Linux kernel routing with FRR and get the virtualized and container offerings to participate in the EVPN as well. But for the bare metal servers, I used some tiny little, like I said, just little NanoPi boxes. I think it's from a company called Friendly Tech or something. Just little two interface mini boxes that'll let me kind of put a bump in the wire to simulate a divided smart NIC, which obviously you'd need a divided smart NIC if you wanted to have a secure solution. You don't want to go throwing a smart NIC and things like FRR and EVPN on a host if a tenant has access to it. You want to separate that out. And given that I don't, have a very expensive card in these machines, I just simulated it with the same technologies but on a much smaller card. We have a functioning server here. I should be able to just log in here. Go ahead and see if I can remember my password for this image. Obviously, with the cloud in it, I set the password, but I could also set SSH keys. So let's just go ahead and see if we can't ping something on our 10.0.2 network. I'm trying to remember. I think I have a container on 7 or 5. Let's try 7 first real quick, see what we have. No, it must be on 5. Okay, let's try 5. That should work. And there we go. So we're running across our overlay now using EVPN, BGP on the back with FRR running. I think we're all good there. Okay, so as I was saying before, we have ZB from Camunda is publishing messages exclusively from that process model. You can see it's kind of an example of some messages that it's putting onto Kafka. So the model, and we talked about this in the blog post, how I basically use ZB as an orchestrated Saga pattern, and it injects messages into Kafka, and then I have a group of event-based microservices picking up all that, and you can see those variables there, and reacting to those and doing all the heavy lifting. So it's working nicely so far. Okay, so this one will go a lot faster. We're going to do virtual machines. So similar thing, I'm using ZB, the Camunda orchestrator, and I've created a basic process flow that I use to create virtual machines. Grab host information, copy the template, create network and disk images, go ahead and create the VM networking, create the VM and start it. So sort of a different flow though. This time I start from a template. So I have a templatized VM, and again I have buttons here that I created to actually manage virtual machines, but this one isn't a running one. I just clone it. So I go ahead and HTML1 for the win. Yay. Give it a name, a couple extra fields in process that I do in flight to set up the new machine. VXLAN, the name, which bridge network I want to use on the host, and obviously the new IP address, so that way I can sort of clone that existing template that's just sitting idle on the disk and go ahead and use it to create an actual running instance of a VM. So it kicked over, and we should have a process here pretty quickly. This one moves fast, so hopefully I can catch it in time so you can see it in flight. They move fast. There it is. It's already up and running. Yeah, we've already done all of that work. We've created the network. We're now right into creating the VM. So we've already, set up everything in NetBox, grabbed all the host information. So we should, there it is. The template, let's see where we have in NetBox. There it is, Video Demo VM. So it has created it. It is active and running. So copied over all the information. You can see it there saying, what parent template's a part of, the host bridge that it's on, that it's a running instance. Implementation is KVM. That becomes important. Netbox doesn't like to do containers just yet. So I have the new Ethernet information interface that I created, and it's got that 33 IP that we assigned it. More importantly, I put it on the right VNI, so I'm on 100. So I should be on that same network that our bare metal server was on. So we're already up and on the overlay network. Again, on the host, I've got this all bridged into various different VNIs. So let's go ahead and jump onto the machine. Here we go. So we hop right in. I should be able to just ping that same container.5 all in the same network. Yep, there we go. So we have a shared network now between bare metal and virtualization across EVPN. So we are all set there. Let's go ahead and do a container now. Again, I have custom fields, the most important one being implementation. Again, it's a kind of a way that I cheat, so I can set up some templates that are containers and some that are actual virtual machines, and Netbox still plays nice. Very similar, except for I don't do, obviously, the disk copy, but the same basic flow. And again, I have the same controls on containers. So we go ahead and give it a name, and let's do video demo container this time. We want to be on the same VXLAN, so we want to stay on VNI 100. Use the same bridge on a host, but obviously a different IP address. So we'll we'll go to 35. Again, this one will move really fast. Hopefully we can catch it. So let's see what we get here. Oh, there we go. Jump over. All right, we are all set. There was no existing container there in the list, you can see. So let's go ahead and grab that. Yeah, we've already grabbed the Netbox template information, created the network, grabbed the host information, so we know what host we're on, and there, boom. Got that little wait there, so we can actually catch it if it goes too fast, and you can see something on the video. There we go, video demo container. It's an LXC implementation. It knows what its parent template was that it came from. Host bridge information. Same basic model with the Ethernet. I've got it all set up. There's a little bit of difference between Cloud Init on the VM when I did it versus the LXC information that I use in its implementation. It's just a matter of setting up the networking on the host versus using Cloud Init. Anyway, so we should be able to log into this one as well. Ping our same interfaces that we did before. Of course, doing a live demo, I can't seem to get my passwords right today. So this should let us in. Eventually there is a dinosaur on this dinosaur tour. Okay, one more time for luck. Let's see what we get here. There we go. Okay, so we're in a container this time, so proving out the third technology. Let's go ahead and make sure we're on the same network. Again, this one is just using Linux kernel routing with FRR, using the route reflector and all that locally on the host, because we're not worried about it's not a bare metal server, so we aren't doing the bump of the wire trick. Let's go ahead and ping our VM. Yep, we can ping across to our VM, so we are successfully riding across that overlay now, which is fantastic. So hopefully this was useful. I need to make another video shortly around what the networking looks like. So I have some work in Netbox as well, where I can automate the creation of the networking. Very simple stuff, just running some scripts, IP scripts, and FRR configs with VTYSH. Go ahead and set things up, as well as create config changes, so on a reboot they persist, obviously undoing them and removing them when it's time to get rid of them. So hopefully, if there's some interest in these video series, I can do something a little different than just typing things, and we can dig into how we accomplish some of these. I could probably create a video around how I made the little EVPN boxes. Those are super handy. They fit in the palm of your hand. It's fantastic. You can just throw them in line on a bare metal server in a lab, and it it allows you to configure those to participate in EVPN on the overlay. A lot of fun. Lets you simulate an actual divided safe smart NIC. Maybe if I get lucky, I can get my hands on some of those smart NICs at some point. We'll see what happens. So hopefully you had fun with this one, and we'll try again, and I'll talk to you on the next one. Thanks.